Wanna go to space. Wanna go to space. Space.
The payload will allow us to accomplish one of the primary goals of our mission, that is, to capture images of Earth from space. The payload of the satellite consists of two cameras, one that captures light in the visible region of the electromagnetic spectrum, and another that captures images in infrared. Our visible light camera is manufactured by a company called Marquette. It has a resolution of 5 megapixels and an internal 32 megabyte frame buffer. It connects to the CDH subsystem using a standard USB interface, just like the one on your computer. The camera has a standard 1-inch C-mount for a lens. The lens we have selected is a compact 18mm model made by Schneider Optics. Our thermal camera is made by DRS Technologies. It is extremely tiny and is in fact the smallest thermal camera you can buy today. It has a resolution of 320 by 240 pixels and a parallel digital interface. We are developing a custom interface board which contains an FPGA and SRAM frame buffer, which will connect to the CDH system using a serial interface. The payload system does not stand alone. We have been working with other subsystems in order to integrate our cameras into the satellite. We've been working with structures to determine where to place the cameras inside the satellite and to ensure that they will be able to withstand the extreme stress they will be under during launch. We've been working with the CDH team to develop the interface between the camera and the CPU and to ensure that our imaging software will work well with the software to perform other functions on the satellite. The EPS team has been very helpful in ensuring that the cameras will have power available when we need it. We've also been working with the simulations team to figure out how fast the satellite can spin before we can no longer take a good picture. So far, we have made significant progress on this subsystem, but there's still much more work to do. Fortunately, a lot of the remaining work can be applied to both cameras, which should cut down on the time required to implement all the things we need. For the visible light camera, we have implemented a significant portion of the drivers which will allow us to talk to the camera. We still need to work out some remaining bugs in the image download routines, clean up the code, and implement power management. For the thermal camera, there will also be a few minor tweaks necessary to the interface board before it can be built. We still need to finish up the VHDL, which will drive the interface board, and write interface and power management software. For both cameras, we need to implement image scaling and compression code and auto exposure and white balance algorithms. For these algorithms to be implemented, we will need working flash memory drivers from the CDH team, as our RAM space is far too small to use as working space for image manipulation. For basically all of these tasks, we have test cases written. If we can build something that passes the test cases, we will be well on our way to having a working subsystem. Of course, it's impossible to say exactly how long this will take to implement, but I believe if we have two reasonably skilled and dedicated people working on it, we should be able to get a reasonably complete prototype of all the functions working by December. What do I wish I knew at the beginning of the semester? The details are important. Just because you can put a component of a subsystem in a nice little box and call it something doesn't mean that it doesn't involve a lot of work to get it done. So make sure that when you're planning a part of the system, you can take it apart enough to really understand what needs to go into it. That way you can budget time accordingly and hopefully develop